Buddy, hey, I have a problem that's similar to a problem way back in 2007, the Singapore Mathematical Olympiad. It's the junior section, problem 35. And it's sort of a strangely worded problem. It says find the largest integer k such that both k plus 132 and k plus 172 are perfect squares. And you're supposed to find the largest k. And again, it'd be tempting to think that your k is going to be a positive number, but that's not necessarily the case, and this problem will illustrate that. Now, so what we do is we just go ahead and set k plus 132 equal to a perfect square, and then k plus 172 equals to a perfect square. So we're forcing the conditions. And of course, a and b aren't stated to be integers, but they have to be integers just by closure here. So if you subtract these two objects from each other, you actually get b squared minus a squared is equal to 40. And you can see that b squared, that would be k plus 172 minus k plus 132, and that just leaves 40, right? The k's cancel. Now, the thing that really helps us out quite a bit here is that this is the difference of two squares. And so we get that 40 is going to equal to the product of these two binomial factors. So it's just a matter of exhaustively going through all the possibilities. Notice that 40 has 8 divisors. You can actually, there's a nice little result that helps you to see that. I mean, you can do it exhaustively if you want to, but 40 is the same as 2 cubed times, I'm going to write 5 to the first emphasis here. All right, now there's a result that says the number of divisors is going to be 4 times 2 equals to 8. All right, and that's just a counting problem basically. But again, you add 1 to this exponent, you add 1 to this exponent, you get 4 times 2, and there's 8 divisors. And here are the 8 divisors: 1 and 40, 2 and 20, 4 and 10, and 8 and 5. Okay, and you just go through the possibilities here. Now, notice you get 2 equations here. When you add these 2 equations, the a's are always going to cancel, and so you get 2b's equal to 41. This is impossible, right? Can't do this, right? To keep integers, right? 2b equals 41 doesn't result in an integer solution. That would be 20.5, right? So we can't even consider that. But here we get a little bit luckier. When you add the equations, the a's cancel always, and so 2 plus 20 is the 22 you see right here, and you get 9, 11 out of this, right? For your a and b coordinate, and you can verify this just by substituting back into these original expressions. Now, if you take a look right here, that implies k is equal to minus 51. Now, the way you would do that is simply just take this value of 9 right here, that's your a, substitute it right here, okay? And so if you substituted 9 right there, you would get 81, subtract 132, and you would get k is equal to minus 51, okay? And in a similar fashion, all the way down here, we get k is equal to minus 123. Again, this is a no-can-do case because 13 over 2 is not an integer, right? So these are the only possibilities. And so our final answer here is actually going to be minus 51. Now, just to make sure you're clear, this kind of confused me at first, but if k is equal to minus 51 right here, this would be 81 right here, right? Okay. And that would make a equal to 9 squared, of course. I mean, 9 squared is equal to 81, right? Okay, and then, and so right here in a similar fashion, what do we get? We get b is equal to 7. So right here, you get 49, right? You get 49. Okay, is equal to minus 123 plus 172. It's kind of strange, isn't it? So we have shown that this is the answer. K equals minus, that's the largest integer. Minus 51 is larger than 123, right? Such that this condition prevails. All right, let me know what you think.